Good afternoon, everyone, and welcome to today's webinar, Effective Methods for Forecasting New Products. My name is Eric Subatis, and I will be the moderator today. We will begin the webinar shortly, but first, let's go over a few logistics. The webinar will run approximately 40 to 50 minutes. We'll save some time at the end for Q&A. During the webinar, you can submit questions using the control panel on your screen at any time. I'll be monitoring these questions throughout the webinar, and we'll compile a list for Q&A at the end. We will also take questions submitted during the Q&A session itself. We'll try to address as many questions as possible. If we don't get to yours, you will receive an email after the conclusion of the webinar. We are also taping this webinar, and we'll email you a link to the video sometime next week. The video will be posted to our website, where you can find a full archive of past webinars. They're all free and a great way to catch up on any past webinars you may have missed. So without further ado, I'll turn it over to Eric Stellwagen and Sarah Darin to present the webinar, Effective Methods for Forecasting New Products.
Okay, well, thank you, Eric. Again, my name is Eric Stellwagen. I am the president and a co-founder of Business Forecast Systems, the company that does Forecast Pro. And I've actually been working in forecasting for pretty much my entire professional career, so going on 33 years now. Originally with an engineering company doing fairly technical forecast generation in support of electric power forecasting. And then starting in 1986, we started this company and developed the Forecast Pro software product line. And I've been working in the field ever since. And with me today to help me present our webinar is Sarah Darin.
Hello, my name is Sarah Darin. I am a senior consultant here at BFS. I have been with BFS for coming up on 2 years now, but like Eric, I have a long history of working in statistics and forecasting, so about 20 years. I came to BFS from, I was a VP at Nielsen for many years. When I was there, I worked in the custom analytics group, so I was exposed to lots and lots of different types of data and even worked on some new product launches. So hopefully that will all come in handy today.
Okay, sounds good. So here's a roadmap of what we're going to cover. We're going to start off with some general introductions, and then we're going to go into different types of new products forecasting. So when you look at the term new product forecasting really covers a lot of ground, okay? And really before you talk about how to approach forecasting new products, you have to really talk about what type of new products are we dealing with. And so this webinar is kind of organized along those lines. Replacement products and product line extensions. That's one type of new product. Products that are new to the company. That's a very different type of new product, and products that are new to the world. So for those of us who haven't really been thinking about these categorizations too much yet, let me just run through them. Consider something like going to the store to buy toothpaste, okay? Something I do from time to time, and I have a favorite brand. I tend to buy a brand called Crest. And when you go into the store and you go to that toothpaste aisle, there's about 20 choices for Crest toothpaste, okay? They have, there's pastes, there's gels, there's cinnamon, there's mint, there's different size tubes. But the bottom line is on that shelf is probably 15 or 20 different types of Crest toothpaste. Each one has a SKU number, stock keeping unit, and whoever works at Procter & Gamble and is in charge of forecasting Crest toothpaste is going to have to generate a forecast for each and every one. Now, when you come into the store next month, you'll probably see a slightly different array of selections, because one of the things they do is they're constantly changing and replacing some of their products. So you might see a tube that says new and improved, and that has a different SKU number, and somebody at Procter & Gamble is now responsible for forecasting this new product. Or maybe you come in and they have a new flavor. That would be an example of a product line extension. Again, these are new products, but unlike something that's, say, new to the world, you have a lot of data. You know what the products that are being replaced or the product lines that are being extended, you have a lot of internal data that tell us about the history of sales. Now contrast that with new to company. So let's say that we're selling toothpaste, and at some point we decide we're also going to start selling toothbrushes because it leverages our distribution and such. So we come out with a line of toothbrushes. Now, toothbrushes are new to the company. We haven't sold those before, so we don't have internal data on the demand for toothbrushes. On the other hand, toothbrushes are not new to the world. Other companies are selling toothbrushes, and I may be able to get information about the toothbrush market as a whole that might help me to generate some forecasts. So again, in contrast to something like a replacement product or a product line extension, the toothbrushes are new to the company and are a little harder to forecast. The third category is the hardest still, which is new to world. So consider something like Google. Google came out with a product called Google Glass. You might remember it was like a pair of eyeglasses that had could project a computer image. You communicated it to it with voice commands. And before they launched Google Glass, they needed to create a forecast for it. And this was truly a new to world product, so they couldn't use internal data. And there really wasn't other people in that market. So it's indeed, when you're really dealing with a new to world product, this is the hardest of all to forecast. So as we go through different methods for forecasting new products, we're going to comment on what type of new products they're appropriate for. So this will be our agenda. We'll leave some time for questions and answers in the end. And as Eric Sabatis mentioned, if you have questions as you go, use the chat facility to ask them. We'll answer them at the end, and if we don't get to yours, we'll answer it by email. So we're going to start with replacement products and product line extensions, and I'll let Sarah talk a little bit about that.
Thank you, Eric. So as Eric was explaining, replacement products and product line extensions, he gave a really nice example of Crest toothpaste. And one of the nice things that happens when you have replacement products or line extensions is you have a lot of internal data that you can leverage when you're coming up with a good forecast for that product. So, and again, when we have the new product type is really going to be dictating what the appropriate approach is. So one thing that you always want to think about when you're doing new product forecasting, and perhaps forecasting in general, is to incorporate judgment and market research, particularly judgment for forecasting in general. These are going to always play a really important role across really all of the new product types that we're going to be talking about. This does not really leverage the existing predecessor product data in this case. And given that, we're going to focus a little bit more on some of these other approaches that we have here, which are more unique to replacement products and line extensions. So let's talk about item supersession. Item supersession is a very simple idea, straightforward, and I suspect that many of you will find it very useful when you're dealing with forecasting replacement products and product line extension. It's also known as mapping data histories, and I think that will be explained very shortly why that's known as that. So the idea of item supersession is when you have a new product, really by definition you have a short data history. When you have a short data history, that is going to limit you in the types of forecasting models that you can use, as well as the quality of the forecast that's coming out of it. So a good example of this is something which is very seasonal. In order to have a seasonal forecasting model, you really need at least 2 years of demand history. For a new product, that's going to be really hard to get to. So the idea of item supersession is that you can create a forecast history which is long enough and robust enough so that you can use a wider array of forecasting models, statistical forecasting models. Often, this is going to be very straightforward. And in the example that Eric brought up, the 6-ounce tube of toothpaste simply being replaced by slightly new and improved 6-ounce tube, that's a good example of a one-to-one replacement process. So you have one SKU, you're replacing it one new SKU. That is going to be a clear, simple mapping of the products. In some cases, and this might be often the case with line extensions, it's going to be more complex because there's not a single product or SKU that is being replaced. You can still leverage your predecessor data to come up with perhaps a slightly more complex mapping, but the outcome is still the same, that you're coming up with a forecast history that you feel is representative of your new product, and you can leverage that forecast history in the statistical forecasting models that you might want to use and come up with a forecast that you feel really good about. So we're going to take a quick look at what's really going on behind the scenes in item supersession. So what we're looking at here is sales for a product that is being phased out. So this is the product that's being replaced. And here we're adding in the sales for the new product. And you can see that there are a few time periods here where the products overlap. So this is kind of that transition period. And what we do in item supersession is we simply merge together these two demand histories to create a forecast history. And when we say merge together, really what we're doing is simply adding together those two histories. And now we have a history that is going to be much more robust for the rest of the forecasting process. So that is item supersession. Again, very straightforward and simple to use and very useful. So next we're going to talk about top-down forecasting. This is very similar to item supersession in that it's really focusing on leveraging your existing data for predecessor products or in some or products that are still out there in the market at the same time. So again, the idea here is that there are a lot of categories where you have a lot of line extensions coming in, you have products being phased in, new products coming in with just subtle little changes to the existing products. And frequently, we can think of all those SKUs or items falling into a single product group. So what we're looking at on this slide is we've transitioned from toothpaste to cough syrup. And cough syrup also, there's a lot of different sizes, a lot of different flavors going on there. But each of these individual items or SKUs really has a similar dynamic across the entire product group. Therefore, it makes a lot of sense to combine them into that product group. When we do that, when we combine the different SKUs and aggregate them into that product group level, at that product group level, we are creating a forecast history which is higher volume, it has more a longer data history, it's more consistent, and for the same reasons that works well for item supersession, it works well for top-down forecasting. That if we are forecasting at that product group level, we're going to be able to do better forecasting models. So let's jump to an example here. And what we're looking at here is cough syrup. So we're leveraging that same example we were just looking at. As an aside, this is actually all real data. So this actually is cough syrup data. We have 3 years of data that we're looking at here. And the first thing that you can really see here is that this is, not surprisingly, a very seasonal product. That as you go into the winter months, you're really seeing a spike in demand going to January, and then going to the summer, you start seeing a fall off in sales. And we're going to kind of dive into what is making up this cough syrup product group. And what you can see here is we have different sizes and we have some different flavors. So if we go through some of these items, this is an 8-ounce size that has been discontinued. It was replaced by a new 8-ounce size. The gray, all of the grays actually represent discontinued items, while all of the green is new items. And one of the things that you might notice here is for all of the new products, they all have a short data history. Most of them under a year, all of them under 2 years. So this is a very seasonal category. at that item level, that seasonality is not going to be captured if we forecast at that item level. So before we really show the benefits of the top-down forecasting approach, let's take a look at what the alternative is, which is really a bottom-up forecast. So at the bottom-up level, what we're doing is we're forecasting at this item level, at the SKU level, and then we're aggregating up to size, and then the cost per product group. So to take a look at what the top-down looks like, let's put in the forecasts. And this red line here is now showing us the forecast, and it's pretty flat. So we see no seasonality. The data looks very different from the history here. And this is not a forecast that we want to take to management or anybody. It's likely people would laugh at us if we did that. So it's clear why this is happening. So if we, as we said, this is summing up the item level forecasts. And as we look at the item level forecast, we can start to understand why it's so flat at the product group level. So what we're looking at here is that new product for the 8 ounce, and the forecast is simply a straight line. And that's probably because it's a simple exponential smoothing model. When you have a short data history like what we have here, you're really limited in terms of what models can be considered. You might be able to do a moving average or exponential smoothing model, but you cannot capture the seasonality. So that is going to be a problem. So as promised, let's take a look at what happens when we do a top-down forecast instead. So very straightforward to do that. I go and select top-down here. And now what's happening is we have this forecast, which looks very reasonable. We're capturing the seasonality that we expect to see. So instead of aggregating up the item level forecast, we are now forecasting at this product group level. And this is the forecast that's being generated. As we go deeper into the item level, we can also see this is the SKU where we had the flat line forecast before. And what we can see now is that this is a much more reasonable forecast. So it is showing the seasonality that we expect to see. And what's happening here is that top-down forecast is being allocated to the item level proportionately. So by doing that, we're able to get appropriate forecasts at that SKU or item level. So let's jump back to the presentation here. So there's some more details about how we generate that top-down forecast here. And just as an aside, our next webinar, as you will see at the end as well, is actually on forecasting product hierarchy. So in that webinar, we'll be going through top-down forecasting in more detail even, as well as some other product hierarchy forecasting techniques. And with that, I am going to turn it back over to Eric to talk about custom component models.
Okay, so again, we're sort of talking about forecasting methods that are effective for replacement products and product line extensions, judgment market research, product mapping, mapping the histories to create a longer history, top-down forecasting, leveraging information higher up. The last one on our list here is custom component models, and this will be new to many of us. The custom component model is a technique that's not only useful for new product forecasting, but also in other circumstances as well. It is a method that was developed by Business Forecast Systems and is implemented in Forecast Pro, and currently it's unique to Forecast Pro. So I'm going to talk about how to use it in general, and then we'll look at how we use it for new products. So here's an example of a long-term forecast. The data here are demand for telephone installations. So these are the phone company coming out and installing business systems into telephone systems into businesses. And whoever generated this forecast, and actually it was me, it did something we don't usually recommend, which is to just forecast out the next 5 years based on the past history. And what you can see is we get a linear trend that goes off for 5 years. Now, what is the custom component model, and why am I using this example? Okay, let's take a look. I'm going to bring up a dialog box here for the custom component model. And the idea behind the model is that there are various different components to the forecast. One component is what I might call the starting point. Okay, so you can see here starting point. And that's where the forecast begins. So that's the point right here. Another component is a trend. And we can have different types of trend, but you can see that underlying pink line that defines, in this case, a linear trend. And another component is a seasonal pattern. And that's represented here with all these different seasonal indices. And that puts the seasonal variation around our trend forecast. And a final component, which we don't actually have in this example, are events. So things like product promotions or business interruptions that may also occur. But one of the concepts here, and this is similar to exponential smoothing, is that the forecast consists of different components. In this case, a starting point, a trend, a seasonal pattern, and potentially events. Now, in a custom component model, we can fit those components to the data, which is what we've done here, or we can customize them, meaning that we can judgmentally make changes to one or more of the components. So in this case, let's say that I think this 5-year forecast is overly optimistic, and that during that 5-year period, according to this, if we look over here on the box, it says the total forecast is going to be 5.3 million. And so we're going to install 5.3 million phone systems during this time frame. Now, I might say, no, I want to lower that. So I'm going to go to what we call a bent custom trend. I'll get rid of that little box. And rather than using this linear trend for 5 years, I'm going to change it. And I'm going to modify it so the total forecast, instead of equaling 5.3 million, is going to be 4.5 million. So I'm just going to put that in there, and I'll hit apply. And you can see that we've bent that trend. We've changed it, and we've modified it so that that total forecast is going to equal 4.5 million. Now, before I proceed, let me just make a comment about something that we're going to talk a little more about as we proceed, which is something called a launch total. So sometimes when we're talking about new product forecasting, we start to talk about how much are we going to sell during a given period of time. We often call that the launch horizon. So let's say that I'm forecasting a new product. I want to come up with the first year's forecast on a monthly basis. Then I would say my launch horizon is 12 months. And then the launch total would be how much do I want to sell in that 12-month period, or how much do I expect to sell. And this is similar, but my horizon here is 5 years. And so during that 5-year period, according to my current model, we will sell 4.5 million units. Okay, so again, this is the introduction to the custom component model in general. This is not a new product example, but we're now going to look at one. But I wanted to get across some basics before we looked at the new product. So what I'm going to do now is actually bring up the same data, but we're only going to look at 12 months. So here is, again, we've got a lot of data, we generated a forecast, and we used the history itself to come up with the trends, the seasonal patterns, etc. Now, here is business connections in a different region, and we only have 3 months worth of history. So now it's a new product, okay? And we don't have a lot of history. And if we just forecast it based on its own history, we get this flat line forecast. It's probably taking a moving average. And again, with only 3 data points, that's reasonable. The problem is we know these are business connections of telephone systems. We know it's a seasonal data set because we have other regions where we've observed that. And we know it's a growing market. So we also expect more of a trend. So this is an awful forecast. It's understandable why Forecast Pro generated it. There were only 3 data points, but we need to do more than this. So let's look how a custom component model might help us. Okay. So now I'm going to bring it up here. It's the same dialog box we saw before. But now I'm going to look at the components, and I'm going to say, well, hey, the seasonal component is empty right now, and that's unacceptable because I know that this series is seasonal. So I'm going to not do automatic. I'm going to go under custom, and I could just go in here and put in different seasonal indices for the pattern, but I can do something even easier than that, which is to pull them in from what we call a helper variable, which in this case is the seasonal pattern from a different series. So I'm going to go ahead and do that. And you can see here are those same indices we saw before, and I'm going to apply it. And now you can see our forecast reflects that seasonal pattern. So that's good. On the other hand, the trend is still flat, and we know we're in a growing industry. So rather than doing the automatic trend, which was no trend, I'm going to go ahead and do a linear customized trend. And I could do this a bunch of different ways, but I'll just go ahead and say we expect to have 750 units a month in terms of a trend line growth. And here's the forecast I end up with. So notice I'm only using 3 months worth of history, but by pulling the seasonality and customizing that component from the overall connection data, I've managed to use the seasonal pattern that we quantified through the total connection data. I've also introduced a trend, which I would not have picked up from these 3 points. So the concept of the custom component model, again, is that you can have some of the components you can estimate from the data, other ones you can customize for yourself. And it can be a very useful model when looking at new products. So let's kind of recap that with a slide or two. Again, the custom component model was developed by BFS and at the moment is unique to Forecast Pro. The components that are not, when is it useful? Well, if we have components that it's hard to quantify or extrapolate. So we saw an example where long-term trend, we really didn't like the automatic long-term trend, so we went and modified it. If the data series is short, like a new product, and we could do things like bring in seasonal patterns from other products. We didn't show this, but it's also useful if you have, say, events. Say you know you're going to promote something in the future that's never been promoted in the past. Then I could bring in this custom component model to customize how that would impact the forecasts. And again, as I mentioned, sometimes you want to enforce, say, a total amount over a specific period of time. And with new product forecasting, we call that a launch total over the launch horizon. And again, the custom component model, if you haven't used it, it's well worth experimenting with. It can be very useful for new products. Okay, so let's continue on. This slide is here if you will be sending out slide sets and information for streaming on demand. This is for your notes. We saw it in action, so I'm not going to comment further on it. We're going to go on to our next type of new product, which is new to company products. Okay, so just as a reminder, the concept here is the example we started to use was we manufacture toothpaste, and now we're going to do toothbrushes. So toothbrushes are certainly new to the company. We've never sold them before, but they're not new to the world. Other companies are out there manufacturing and selling toothbrushes. So when forecasting new to company products, you obviously don't have internal data because you haven't sold these things before. On the other hand, you may have external data available. And maybe this is coming from data providers like AC Nielsen or IRI. Maybe it's coming from industry consortiums, what have you. But you may have some access to internal data, or external data rather. So how do we approach the forecasting for new to company? And the answer is there are a number of techniques that can be used. Judgment and market research is always on our list with new product forecasting. The custom component model could also be used. The one I'm going to look at now is something called assumption-based modeling, okay? And we're going to do this almost completely with an example. An assumption-based model is usually used for new product forecasting, and it's often done in Excel. And there's a couple of different situations where it can be particularly useful. And this example, which is a very simple one, is the idea is let's say I'm working for a pharmaceutical company, and we're going to be developing a new drug, and the question is, will it be profitable? So we need to come up with a forecast. And with an assumption-based model, you start by making some assumptions, and here they are. Our first assumption is it's going to take 24 months to develop the drug. That leads us to the second assumption, which is it's going to cost us $60 million to develop the new drug. Our third assumption is in order to sell the drug, we'll need approval by the Food and Drug Administration. And we currently think that for this drug, we'd have an 80% chance of getting approval. The population, so the patient population that could benefit from this drug is 500,000 people. And we're expecting a 35% market share for our drug. And that would be at a cost to the patient cost of $450 annually, and our cost of goods at $10. So the main idea is I have these assumptions, in this case 7 of them, and I've put in what our assumptions are for each. That yields a forecast for the first year of sales, where I would actually recoup all of my development cost and show a very small profit, $1.6 million. In subsequent years, we'd be making a lot of money, $61 million a year. So clearly, at this stage of the game, before we started product development, our assumption-based model is leading us to think this would be a very good endeavor. This would be a very profitable thing to do. Now, the problem often is when developing a long-term drug is there's a lot of unknowns. And as you get going, some of your assumptions may change. And in an assumption-based model, an important part of this is periodically we're going to come back to our assumptions. We're going to jeopardize them. We're going to say, are they still correct? And we're going to make adjustments to them, and that will change our forecast. And the cardinal rule with assumption-based modeling is you only change the assumptions. You never change the forecast directly. So we don't come out around the table and say, well, we thought we'd make 61 million. How much do you think we're going to make now? No, what we do is we say, we thought this was going to take 24 months. Well, guess what? We've been at it now for almost, say we've been at it for 8 or 9 months, and we're behind schedule. So I'm going to adjust that assumption. And rather than 24 months, I think 30 months is more realistic. Okay? So now we have a new assumption, and the assumption is that our development cycle is going to be longer, and that means our costs are going to be higher. And here's our new forecast. In the first year, we're going to lose $13 million. Okay? Not really lose it. We're just not going to make back all of our invested money, but we're still looking good further out. Okay? So probably after we've made this round of assumption changes, we're still moving forward with the project. So now let's say a few more months go by and we go into clinical trials, say, and unfortunately the drug seems to have a lot of side effects that we didn't anticipate. So now we're going to go to our assumptions again. And how do they change? Well, the development is still looking like 30 months. On the other hand, since the trials aren't going well, we're thinking that approval rating, that we have an 80% chance. That's probably not realistic anymore. It's probably closer to 40 now, so we'll change that. And the market share, if there are side effects, well, the 35 is probably not going to be good either, and so maybe we'll lower that to 20. And here's our new forecast. And now we've got some issues, okay, because it looks like we're going to be losing $57 million in the first year, and the subsequent years are nowhere near as rosy as they used to be. And maybe at this point we look at this and say, you know what, we should probably stop development. That this looked like a good idea when we started the project, but now that we're 12 or 15 months into it and we know a little more about how this is going, it doesn't look like a winner anymore, and we should take our development money and put it into other drugs, etc. So this is obviously a very, very simplified example. A real example like this would have many more assumptions. It would have formal review times where you go through the assumptions. They often call those gates. So we get up to a gate, we review the assumptions, we decide, do you proceed through the gate and continue, or do you stop? So again, just a simple example to give you a feel for it. But again, when we're talking about products that are new to the company, that were under development, but we don't have internal data that we can simply work with and extrapolate, then these are the types of approaches that we use. A couple of more techniques for new to company: market share forecasting and forecasting by analogy, and I'll let Sarah enlighten us about those.
Okay, market share forecasting. So when a product is new to the company, there's a tendency for that organization to really focus more on the market as a whole, as opposed to just that individual new product. So because of that, there's a tendency for organizations to really focus on the market share they expect to get, as opposed to unit sales. So because there's no internal data, companies are going to really focus on how they can gather external data. As Eric was mentioning earlier, there are lots of different sources for getting industry data. There are market research groups like Nielsen, IRI, IMS for pharmaceutical data. There are a lot of smaller market research out there that can come up with very good industry-specific data. And working with these market research groups can really provide considerable insight into the size of the current market, as well as its composition, and start to give you an understanding of how much market share you might be able to expect. There are also some very good formal research techniques that can, such as discrete choice analysis, that can start coming up with very good statistical estimates of what your market share is going to be. So these are all, great things to get into. Once you have that market share forecast and you have a good understanding of your size, the size of your market, it's pretty straightforward to get to that unit forecast. Simple multiplication, really, of market share and the market size. It's worth noting that forecasting market share and assumption-based models tend to be slightly earlier in the product cycle, as opposed to some of these other models that we've been talking about. So in a way, it's useful to think of the outputs from these types of models as inputs into some of the other models. So for forecasting market share and assumption-based models, these are often useful techniques for coming up with the launch totals across a launch horizon that Eric was also talking about with custom component models. And it's also very useful for our next topic, which is forecasting by analogy, or looks-like analysis, which also leverages this concept of a launch total. So what we're doing when we're forecasting by analogy is we're assuming that the initial demand pattern is going to look like or be similar to the pattern of a similar new product launch. So using that, we get what we call a launch profile that we can use in a forecasting by analogy model. Forecasting by analogy is something that can be done both before a launch, when you have no demand history, and it's also a really good way of calibrating how the launch is going as the history comes in. So it can be used once you have some short history, and you can start making adjustments to your forecast based on that incoming history. So on this slide, we're going to take a look at a launch profile. The first thing that we really want to focus on is this graph here. And this is showing sales across the first year of our analogous product launch. And really, what we want to focus on here is the pattern more than the total sales level. And what you can see here is in the beginning, the first 3 months, there's this very rapid increase in sales, probably part of the pipeline fill. And then we see sales falling off into what is likely going to be more of a steady state level going forward. So over here, we can see the underlying data for this graph, and this is just the sales over the first 12 months of that new product launch. But what we really want to focus on is more the relative percentage and the cumulative relative percentage over here. And again, the reason for that is what we really are focused on is the pattern that we see in that first year of sales, and not necessarily the total level of sales coming in for this analogous product. So what we can see here is in the first month, there was about 4% of the sales, first year sales coming in. Second month, a little under 13%, so 12.7%. and so on. So this is the distribution of sales across the initial 12-month launch period. And then over here, what we have is a cumulative relative percentage. So if we look at this 31.8% for month 3, what that means is that within the first 3 months, we saw 31.8% of the total first-year sales. Now, the reason that we really are focusing on this right now is that is going to be very relevant when we start thinking about estimating launch profiles as we start seeing data come in for a new product launch. So let's actually jump to an example here. So what we're looking at here, not terribly interesting yet. We're starting off with a new product that hasn't launched yet, so we have no sales, hence our red forecast line of 0 sales down here. So we need to put together a forecast for this new product, and we want to do that using forecasting by analogy. So when we read in this data, we read in a couple of possible profiles to use in our forecast by analogy models using a helpers variable. What we're looking at here is the profile that we want to use for this new product. And you can see that it looks very similar to what we just saw on the previous slide. So to apply this profile, what we're going to do is we're going to go down to by analogy here, and we'll see this dialog box pop up. And there are a couple of decisions that we have to make here. So the first is what analog variable do we want to use? So we're going to go ahead and select the profile one that we just looked at. Over on the right-hand side, we have a couple of other decisions that need to be made. So the other 2 pieces of information that we need are what are the launch total and what is the launch horizon. So we're going to leave the launch horizon here at 12. Now for the launch total, there are 2 different boxes that we can think about here. In the estimated launch total, we have NA, and that's because we haven't launched yet, so there's nothing that can be used to create an estimated launch total. So down here, this is actually the sum across the profile that we looked at before. We don't necessarily expect the sales to be, the total sales of our new product to be the same as our analogous product. But we've done some market research. So perhaps we've done an assumption-based model, perhaps we've done a market share model, and that analysis has told us that a reasonable launch total is going to be 500,000. So let's go ahead and put that in here. And click OK. And what we can see is we now have a forecast that we can deliver. It looks very, very similar to the profile that we looked at as expected, but if we summed up the sales across these 12 months, we would actually see that it sums to 500,000. So now let's jump ahead 3 months. And we started, the launch has happened, we've started getting some data about the launch. And we want to think about what our forecast should now be going forward. So starting off, let's take a look at how well the model that we had before launch is performing. So to do that, I'm going to go actually and just apply the same model to what we have after 3 months of data. So the green line here is our 3 months of data. And here is what our forecast looks like. And this is going to be the same as what we saw for the product 0, so the exact same forecast. And what I'm going to do here is now put in the fitted, so we can get an understanding of how well this model has been performing in the historical demand period now. And we can see that while the pattern looks very similar, the actual sales level is well below what we had initially anticipated. So this would certainly suggest that we might want to revise our assumption that we're going to get 500,000 units in the first year. So we're going to go back and look at what's going on here. So we can see that we're still using this 500,000 based on this checkbox here. But we can also see that we now have an estimated launch total of a little bit over 400,000 now. The way that we're getting to that number is if you think back to the Excel sheet where we saw demand, we saw 31.8% of sales coming in the first 3 months. That 31.8% is being used to project the 3 months of data to the whole first year. So basically we're taking the sum of the sales in the first 3 months and dividing by 0.318 to get to this estimated launch total. And let's go ahead and apply that. And once we adjust that assumption and use the estimated launch total, we can see that historically the data is fitting much better. And this revised forecast is likely going to be more accurate going forward. And it's probably wise to go and adjust some expectations about what sales are going to be for the remainder of the year. So let's jump back to the presentation. This is pretty much just a summary of what we just went through in our live example. And I'm going to turn it back over to Eric to take us through new to world.
Okay, so we've looked at all of the categories except for the last one, which is new to world forecasting. And as we mentioned before, this is really the most challenging of all of them because you not only do you not have internal data, but you have other companies' experiences aren't necessarily relevant since it's truly new to the world. What approaches can you use? Well, we've got a lot of our old friends here. Judgment, market research, assumption-based models, forecasting by analogy, custom component. Some of these require you've got a little data before you start to use them in this context. The last one is new, diffusion models. And of the so-called diffusion models, the most popular one is called the BAS model. And so we're going to talk a little bit about this. We're not going to actually show it as a demonstration, but I want to get across a couple of concepts. First of all, the BAS model is only used to forecast first-time adoptions or first-time buyers of new-to-world products. And it's really designed around how people adopt new technology. But it's a little different in that we're not after total demand of a product over the first year. We're saying how many people are going to try it. And if somebody is a repeat buyer, it's not part of the model, okay? It's only first-time purchases. It envisions that there are two types of people when it comes to trying new technologies. One is what we call early adopters, and in the BAS parlance, that would be innovators. These are the people who love new technology, and they want to be the first ones to be using it. They're intrigued by it. It's the type of people that would be camping out with sleeping bags in front of Best Buy when, you know, Apple's going to release the latest gadget. The other type of consumer in the BAS model world is what's called imitators. These are people who are not early adopters. These are more wait and see. So this is someone who says, you know, before I buy something, I want to read a couple of reviews, see what other people think about it. But again, I'm not going to be camping out at Best Buy to be the first one to use it. Okay, the BAS model can be used with or without historic data. And it really models the adoption rates of new technology. And some people call this an S-curve model because of this graph. This graph is, again, cumulative adoptions of our new product or our new technology. So you launch the product, and there's a certain amount of sales levels, and you can see that sales are increasing, the rate of adoptions is increasing. As the early adopters are getting it, as they're starting to get a buzz around, you know, if it's good or bad, then some of the imitators come in, and the level or the rate is increasing until you get to a certain point, which we call an inflection point, where the rate of adoption starts to slow, and we start to saturate our market, and the number of first-time adopters it starts to level out, and eventually you'll get all the first-time adoptions that you're going to get for a new technology. So this is what the BAS model is all about. It's saying, how does a new technology, how is it adopted? And how quickly does it rise, and how quickly does it saturate? To build the model requires 3 different coefficients. There's one we label P here. It's called the coefficient of innovation. This is the rate of new adoptions. Okay, so how eagerly are the early adopters adopting this? The other is a coefficient for the imitators. We call that Q. And again, it's how rapidly are people jumping on the bandwagon. And the third one, M, is the total market size. And again, this would be something prior to the launch we'd come up with through market research. In this example, I've got it set to 1 million units. So setting the P, Q, and M is required to build the model. You can do that judgmentally. Or if it's already been launched and you've got at least 5 data points, it can be estimated from the product. So the BAS model has a considerable body of literature. There's a lot of publications and articles about it, mostly in the marketing literature. And they include things like P's and Q's for different types of technologies. How well does this work? Okay, it varies. And for me, because I tend to be all about, can I get an accurate forecast for new products prior to launch and shortly thereafter? The BAS model is a little lacking. So I want to know if I'm right here, I'm a couple months into this, you know, where's the inflection point and what's my total market going to be? And with the BAS model, if you look at that stuff empirically, it doesn't always perform that well. What it does perform well in is after you're up here, that after that has been penetrated, we can go back and get the PQs and Ms and really get a good idea of this curve. So I think as a model of behavior, understanding where new products are being adopted and the type of consumers' attitudes, I think it's a good model and I think it's useful. In terms of my ability to take a product like Google Glass and prior to launch to being able to really accurately forecast what it's going to be, not so much, okay? How about a couple months into Google Glass? Probably also not so much. And things like by analogy and other methods may work better for that. On the other hand, after it's played out, looking back and understanding the adoption rates, I do think it's useful. So again, I know that's a quick overview for a fairly complicated method. For those who use Forecast Pro, we have some tutorial exercises on the BAS model, and you might want to take a look at that. And I've also got a reference coming up in a slide or two on an excellent little book that has a good coverage as well. So let's summarize and take a few questions. The type of new product will often dictate the approach when generating a forecast. Judgment and market research will always play an important role in new product forecasting, pretty much by definition. When forecasting replacement products or product line extensions, we have a lot of data. We can leverage the data for the predecessor products, we can leverage the data at the category level, and there's a lot of things we can do. When forecasting new to company or new to world, things are harder. We don't have the internal data. We may or may not have external data that helps us out. Okay. This is a book. It's written by Ken Kahn, who is an authority on new product forecasting. It's very much written for a business person. It's only about 100 pages long or so. And if you're interested in getting a good overview on all the methods we've covered, as well as many others, I would highly recommend this book. It's a nice little reference. Okay, so a couple of things to mention before we go into the questions and answers. As Eric Subatis mentioned in the beginning, we are recording this webinar and it will be available for on-demand streaming probably next week. Everyone who signed up for the webinar will get an email telling them when it's available and how to access it. This is a quarterly webinar series, and the next webinar in our series is on forecasting product hierarchies. So different strategies, top-down, bottom-up, things like that, on how to get more accurate forecasts by leveraging different levels of aggregation in your data. Both myself and Sarah will also be presenting that webinar. It'll be on April 5th at 1:30, so we'd hope to have you join us at that time. On forecastpro.com, registration is open. I know it's a ways off, but if you register now, we'll make sure to send you a reminder as we get closer to the event. I also want to mention that we have a 3-day workshop that we're going to be holding in Orlando in March, March 7th through 9th. This class is really a comprehensive class on all different approaches to business forecasting. It integrates both learning about the methods and how to apply them with working with your own data and leveraging the people in the room and all their experiences. So these are always a lot of fun. If you haven't joined us for one in the past, I'd recommend looking into it. We have a website up that describes the agenda and has registration forms, and feel free to visit forecastpro.com and check it out. I do want to mention that we've been using the Forecast Pro software during the webinar. If you are not familiar with it and you'd like to become more so, we'd love to tell you about it. The best way to learn about software is to sign up for a live, free WebEx-based demo. We can even use your own data if you wish. And if you are interested in getting a demonstration of Forecast Pro, you can actually use the chat box and say, sign me up for a demo, or go onto forecastpro.com. There's lots of information. But again, if you're interested in learning more, we'd love to tell you about it. Other resources, I think I'm actually just going to pop right over to forecastpro.com and point to a couple of little things. One is, again, if you want to register for the next webinar, it's right here. If you want to learn about the forecasting workshop, that's up here. We have the webinar archive. We've got about 20 or 30 hours of pre-recorded webinars on different topics. It's all free. Feel free to leverage that. And for those who aren't signed up for our blog, we've got a blog with lots of useful information on different things that are of relevance to business forecasters. So again, lots of resources to help you, and be sure to check them out. So we've come to the end of the formal presentation. We have almost used all our time, but we do have time for just a few questions before we wrap things up. So why don't we proceed to that?
All right. So a few questions. If you think of any, just shoot them our way. Even if we don't get to them, we'll reach out. But we'll start with this one, which isn't necessarily directly related to new product forecasting, but it's an issue that crops up pretty frequently. If a new product might cannibalize existing demand for other products, how might I approach that, and can that be modeled?
Okay. I'm going to take a crack at that one?
Sure, go ahead.
Okay, so those of you who have seen, ever seen me talk on forecasting will know exactly where I'm going with this. My answer to almost everything is it depends, okay? But let's think about product cannibalization, because with new products, particularly with replacement products, product line extensions, this is very real, okay? So one of the techniques we looked at was top-down forecasting. And there is a question of, at a group level, so which is going to be including, again, the new products, both the replacements and the new ones, is the introduction of the new product increasing the overall group level? See, if it's not, then you're just changing the mix, and then you really are just looking at cannibalization. But usually, you don't launch new products in order to cannibalize your existing ones. You do it to expand the market. So one of the things you want to look at is the group level sales. The other is how it's introduced, so that there are times where you introduce a new product and it does have a cannibalization of the others. And the question is, how directed is it? And for that, you kind of have to know how the products are being replaced. So in other words, some people will phase out an old product and then replace it with a new, so they'll sort of sell it through. Others will put both on the shelf, and in which case you may have product obsolescence. So you do need to know a little more detail to really understand how cannibalization will work. But it's definitely an issue, and it's definitely part of the challenge in new product forecasting.
One thing I would quickly add to that is that's another way that you can leverage market research to understand how much cannibalization you might expect and adjust your forecast according to what market research is telling you. And then as your data comes in, if there is cannibalization happening, you're going to see that in your data, and you'll be able to adjust your forecast accordingly as you see it roll out.
Okay.
All right, we're a little over time, so we'll do one more question. Can you discuss or elaborate on strategies to identify similar products? In particular, if I have a lot of SKUs and there isn't a clear winner, so to speak, or how can I decide if I may have many candidates for a new product analogy?
Well, I mean, one thing that you can try is looking at different assumptions, right? So you can look at some different possible candidates and see which one gives you the forecast that by your judgment seems reasonable. There is also the option, and I'm not sure I mentioned this fully when we were talking about creating a profile, you could actually average across previous launches as well. And that way you're kind of like, you're not dependent on a single choice, and you're really leveraging across multiple new product launches.
Yeah, and the only thing I'd add to that is, again, things do get specific very quickly. I worked with a company that did home video, so DVD sales, and probably at the time VHS sales. But their analogies were based on things like what was the genre of the movie? You know, was it an action? Was it a romantic comedy? What was the star power? What was the budget? And they had a very quantified way of combining different launch profiles from different movies based on the attributes, and indeed they were blending. So they'd have 5 or 6 titles that they thought were similar, and they would combine them in a weighted way to get the analogy series. So again, I know those who've seen us talk before know that our favorite answer is it depends. But there's truth to that. Things do get specific pretty quickly, and you do have to think through your own situation to determine the best approach going forward. It's what makes forecasting hard, and there's no harder type of forecasting than new product forecasting. Okay, well, again, I want to thank everyone for taking time out of their day and joining us. I hope you found it worthwhile. I hope you've picked up a few things and learned a couple of things. And we hope to see you all at our next webinar in April. So thanks again.
And perhaps in Orlando.
And perhaps see you in Orlando. Okay, thank you.